Hello everybody, and welcome to my presentation for MS579 SQL Injection. So, what is SQL Injection? Well, SQL Injection is a technique through which an attacker can execute their own malicious SQL statements, generally referred to as malicious payload. Though the malicious SQL statements, through the malicious SQL statements, attackers can steal information from the victim's database. Even worse, they may be able to make changes to the database. So, applications will often need dynamic SQL queries to be able to display content based on different conditions set by the user. To allow for dynamic SQL queries, the developer often concatenates user input directly into the SQL statement. Without checks on the received input, string concatenations become the most common mistake that leads to SQL injection vulnerability. Without input sanitization, the user can make the database interpret the user input as an SQL statement instead of data. In other words, the attacker must have access to a parameter that they control, which goes into the SQL statement. With control of a parameter, the attacker can inject a malicious query, which will be executed by the database. If the application does not sanitize the given input from the attacker control parameter, the query will be vulnerable to SQL injection attack. So in other words, in layman's terms, basically what you can do is, if you know something about the web application you're trying to get into, you can try to use SQL statements or commands in order to retrieve information. You can hack databases, tables, you can get passwords, usernames, all kinds of data if you're clever enough. Unfortunately, it's a really big problem, as we'll see in the upcoming examples. So there are a lot of different types of SQL injection attacks. I'm just going to cover a couple of them with this assignment. Now, I had to use TryHackMe and a special room called SQL Injection, and I had to go through it in order to learn this stuff, and that's why this presentation is taking place, just to let you know. So the first one we're going to discuss is in-band SQL injection. Now, in-band SQL injection, it's considered the easiest type to detect and exploit. It just refers to the same method of communicating being used to exploit the vulnerability and also receive the results. For example, discovering an SQL injection vulnerability on a website page, and then being able to extract the data from the database to the same page. So in other words, you're basically just brute forcing some stuff and seeing what comes out of it. You're using the URL basically and adding some kind of SQL tag into it and seeing what happens. I have an example right here. So in this example of in-band injection, I injected an SQL command to the URL to get the desired result. In this example, we can change URL to SQL code to access usernames and passwords. Air-based, there's also other different types of in-band SQL injection samples. There's air-based SQL injection and union-based. So air-based is a type of SQL injection that's most usable for easily obtaining information about the database structure, as error messages from databases are printed directly to the browser screen. This can be often used to enumerate a whole database. So with these error messages, you can get feedback from these error messages, and once you strike gold, those error messages basically go away. Union-based SQL injection, this is a type of injection utilizes SQL union operator along a select statement to return additional results to the page. In other words, we're basically adding something to the end of a statement in order to see if we can concatenate something together and get a result. So like a username and password type of thing. And that's what I did with this. This method is the most common way of extracting large amounts of data and an SQL injection vulnerability. So you can see right here, we have the level 1. This is the level 1 part of it. And what we do here is right up in here, this website here. So if you see here, we can use some SQL code, and then we can get the administrator, the usernames and passwords. So how this worked is, you see this ID here equals 1. Well, if there's an ID that equals 1, there's probably other IDs. So you just have to go through the different IDs and then add some of this SQL stuff into it, and hopefully you'll break it and be able to get the password and username. So in this one, we wanted to get Martin's username, so we did. We hacked into Martin and we saw a password, and we were able to get that. And that's how that works. That's probably the extent of my real skills in this. I'm going to be honest with you. I'm not a hacker. I've got no ambition, no desire, and no love for hacking whatsoever. Just to be honest with you, I think sitting there hours upon hours trying to get in other people's stuff is not only degrading yourself, but it doesn't really say much for you as a person, and it doesn't say much for you as a company. It doesn't say much for anybody in general that does something like that. It's basically thievery, and the people that do this, to me, are bored people who have no lives, and basically they just sit there and because of that, they want to ruin other people's days. So they try to take other people's stuff. There's an old saying, you'll make up something in order to get something because you have nothing. And pretty much that's the way it is. I don't like it. So I'm never going to be a hacker. I'm never getting into cybersecurity. So just take that with the way it is. I like the class and everything, but I don't like what this is, if that makes sense. Anyway, moving on. So here's another type of an injection attack called a blind SQL injection, SQLI for short. So unlike the in-band SQL injection where we can see the results of our attack basically on the screen by a lot of times getting an error message, the blind SQL is when we get basically nothing to confirm whether injections queries were in fact successful or not. And that's because error messages have been disabled. But the injection still works regardless. It might surprise you that all we need is a little bit of feedback, successfully enumerable database. There's also another one called authentication bypass. One of the most straightforward blind SQL injection techniques is when bypassing authentication methods such as login forms. In this instance, we're not really interested in retrieving data from a database. We just want to get into the system. We want to get a password and a login, a username. Login forms that are connected to the database of users are often developed in such a way that web applications isn't interested in the content of the username or password, but more in whether or not the two make a matching pair in the user tables. In basic terms, the web application is asking the database, do you have a user with the username of this and a password that belongs to this? If the data replies with a yes or no, it's true or false, and depending on the answer dictates whether the web application lets you proceed or not. So in other words, you can trick the system, okay, even though you don't have the username and password. If you can get the system to generate a true, okay, and say, oh yeah, we do, then you can get into the system. And that sucks, because binary is like the most simplest language on the face of the earth. Ones and zeros. Yes, no, true, false, on, off. That's it. It's simple. You just have to. All you have to do is flip a 0 to a 1. So in this example, we use blind SQL to get into a website by bypassing the username and password. We can't get direct feedback, so this is a brute force attack. Again, yes, that's what I basically did. What I did is I kept getting into the into the system by using select and then trying to get usernames. So basically, I just went into this and I said, if the username has this letter in it, and if there's a password in here, can we get a password that equals 1, right? For true. And that's what happened. It actually worked. I know it sounds weird, but it's really easy to do, unfortunately. So here's another example. Boolean based, like we just talked about, the true and false stuff. This is a big one. I see this all the time being an embedded systems programmer. I work with ones and zeros on a daily basis, so I know the power of ones and zeros, and on and off and yes and no and all that stuff. And as a computer, interprets it, they're absolutes. Yes is yes, no is no. A 0 is a 0 and a 1 is a 1. And you can't really befuddle that. So what it is, Boolean based SQL injection refers to a response that we receive from our injection attempts, which could be a true or false a yes or a no, an on or an off, an input or an output, or any response, or a 1 or 0, I should say, or any response that can only have two outcomes. That outcome confirms our SQL injection payload, whether either successful or not. On the first inspection, you might feel like this is a limited response, and it won't provide much information. Still, with just these two responses, possibly enumerate a whole database structure and contents. So yeah, this is how I was able to get a password. So check this out. So with trial and error, I had to inject different commands to get the true and false responses. Although it was time consuming, I was able to get the password out of the database by using this type of injection method. So, I basically was kept asking it, the administration pass, if you have a username admin, I'm sorry, I'm starting a little bit. If you have a username and the username is admin as an administrator, I can also ask, does this number in the password exist? Does this number in the password exist? And you get a true or false answer out of it. And because of that, I was able to get the password, and it worked. So, there's also a time-based SQL injection, and it's very similar to the Boolean-based one, and the same requests are sent, but there's no visual indicator of your queries being wrong or right at this time. Instead, your indicator of a correct query is based on the time the query takes to complete. This time delay is introduced using a built-in method such as the sleep function. Alongside the union statement, the sleep function method will only ever execute upon a successful union select statement. Let me show you an example of this. So for example, I started probing the URL for names of tables. So how was I able to do that? Well, I would ask if this letter was in the table, and if it was a no, well, there would be no time delay, okay, and it would say okay. But if there was something, it would delay. You wouldn't get a response right away. Like 5 seconds would go by, and then it would say okay. Then I knew, okay, yeah, there's something in there. So I basically just started writing these letters down, right? And they were mixed in order. They weren't in order or anything, but then I was able to make a password out of it and a username. And it worked. Boom. Oops. I dropped my mouse. Anyway, so I won the room. Look at that. Congratulations, right? So, you got to be responsible when you do this. And ethically, I believe that we have a responsibility. If we stumble onto something like this, we should report it. And let me give you an example of this. This actually happened to me at my job. So one of my job functions at the time, when I was working for this company as an embedded systems programmer, was to reverse engineer automotive products. And one of them was an OnStar unit. What happened was the company that made the OnStar units discontinued them, but the cars still used them. So my company was interested in obtaining these units, reverse engineering them so we can repair them and put them back in the field. But in order to do that, I had to do some research, which means I had to get in their website, and then in their website I had to get into their catalog, and in their catalog I had to get into their database, which I thought was all public domain. However, it wasn't. I didn't even mean to do this, but I broke into their database and I caused a data breach. And I realized what had happened. And believe me, I got information out of that was I shouldn't have had my hands on, okay? And I had to notify my supervisor, and he was like, oh boy, I could have gotten in trouble for this. But because of the fact that I didn't know what I had done, and well, at the end result was okay, I didn't get fired, but I could have. So what happened was we had to actually contact the company and let them know that we inadvertently caused a data breach, which was the ethical thing to do, right? So I had to stand my ground, and I almost got fired for this, even though I didn't exactly know what I was getting into. I was just doing research. I wasn't trying to steal anything. I was just trying to find information about this certain product so I can basically, get into the microcontroller using what we call JTAG and be able to get into the microcontroller and start getting information out of it using like the CAN bus, and that way I can get this information out of it, these codes, like hexadecimal codes, that I can figure out what it's doing, like turning on a blinker, or sending a message or sending a phone call, or something like that. But anyway, in the end, yeah, that actually happened. So I just wanted to put that in there because part of the assignment was to describe something like that. It actually happened, and yes, there are certain things that I feel you should do, and you are taking the responsibility on yourself, but you owe it to the other people that if you did find a breach, to notify them and to let them know so they can take care of it. And that's just the nature of the beast. Anyway, that's the end. Thank you very much. My name is Jeffrey Koss. I am a Master of Science and Software Engineering student at the University of Advancing Technology. Thank you very much. And if you like what you see, give me a good grade, because I love them. Thank you. Bye-bye.